All right, so now we're talking about law of cosines, which is when we don't have enough information to use law of sines. So there's really kind of 6 formulas here, but you really only need to kind of memorize one of them. This tends to be the one I memorize for when you're solving for a side length. You could even find alternate versions of these, of course. When you're solving for a length like c, and this formula equals c squared, you will need to do the square root of each of these. And since c is a length, we only want the positive case, so you don't need to do plus or minus. These are just if you're solving for an angle. So if I'm solving for the angle at, say, C, right, like say C in this triangle, this is just this formula rearranged to get C out of cosine. So you subtract the A over, subtract the B over, divide away the 2AB. So subtract A over, subtract B over, divide by negative 2AB. And then to get C out of cosine, you would need to do the inverse cosine of both sides. And so that's where these formulas from the right come from. It's really just one formula applied 3 different ways, I guess. And then these are for angles, which is just manipulating this formula. Anyway, let's find some missing lengths here. Find the length of BC. So we can call this lowercase a if you'd like, because it's opposite side A. Now, again, I do know one angle, but I don't know the side across from it. So this is why we cannot use law of sines. So since we're solving for a, we'll go ahead and use this top version. A squared equals b squared plus c squared minus 2bc times the cosine of the angle at A. So plugging in here, what do we know? We don't know a squared yet, of course, but we know b squared. So this would be b, right? 28 squared. And it doesn't actually matter which one of these is technically b or c, because the operations that we're going to do to both of them will be the same, essentially. We're going to square them and add them together, and then subtract 2 times each of those values. So if you put them in a different order, it won't make a difference. So minus 2 times b times c, 28 times 25, times the cosine of the angle at A, which is 66 degrees. Now again, to finish solving for A, we're going to need to do the square root. That's a pretty terrible symbol, but hopefully you get the idea here. Yeah, I can't do that. All right, there we go. So now we want to type that into our Desmos calculator. So the square root of 28 squared plus 25 squared minus 2 times 28 times 25, oops, if I can type, times the cosine, holy moly, come on now, times the cosine of 66 degrees. So I'd probably make this a little wider here so we can fit it all on the screen. And make sure your calculator, of course, is in degree mode, so your calculator knows 66 is degrees and not radians. And it tells me my missing side length, which seems pretty reasonable here, is about 28.97, which if I'm rounding to the nearest tenth, means we need to actually round this up to 29.0. So A is approximately 29.0 kilometers. Pretty big triangle. All right, our next one, we're going to need to do kind of the same idea. In fact, this would be a great one for you to try out and see if you can find side length AC or lowercase b. So again, when you're setting up this formula, the side length you're looking for, squared, equals the other 2 sides. Like all of this part is the other 2 sides, and then cosine of the angle opposite your side. So if you kind of remember that pattern, you don't need to like memorize all 3 of those, etc. So anyway, try problem F, unpause the video when you're done. All right, so you should have come up with about 12.6. Our missing side is 12.6. So you can see all of that typed into Desmos here. Here was our equation, and there's our answer, 12.6 centimeters. Okay, now next we're going to look at a few examples where we'll need to use law of cosines to solve for a missing angle. Okay, so on our next one here, we're going to need to solve for a missing angle. So notice we have a non-right triangle. We only know one angle, but we don't know the side opposite it. So in order to solve for any of these other angles, we're going to need law of cosines. However, to use law of cosines, if you notice, we need to know A, B, and C. In other words, all three side lengths. And right now, we don't know side length A. So in fact, before we can find this angle, we need to do what we just did in the previous two problems as an extra complication here. So we need to find this. So let's do that first. To find side length A, we know A squared equals B squared plus C squared minus 2BC times the cosine of the angle at A. Okay, so let's plug in and find A. All right, so we're plugging in for our other two sides, 18 and 22, right, in our formula, and cosine at 58 degrees. And that tells me my missing length, rounding to one decimal place, is about 19.7. Okay, so now we have enough information to solve for the angle at B. So we can go straight to this formula. Again, this is just this same type of formula manipulated to solve for A and get A out of cosine. So we can go ahead and use the one that's labeled as B. So B here is equal to the inverse cosine or arc cosine of B squared, so side length B, which we'll call this one and this one. So 18 squared, it's the side opposite our angle, minus the other two sides, 19.7 squared and minus 22 squared, all over negative 2 times A. These are the other two sides here, so 19.7 and 22. So I need to do the inverse cosine of all of that. So in Desmos, your inverse cosine is under function again. So inverse cosine, press / for your fraction, 18 squared minus 19.7 squared minus 22 squared, all over, all over negative 2 times 19.7 times 22. And it tells us our angle going to one decimal place is about a 50.8 degree angle. So it's about 50.8 degrees. So angle B is about 50.8 degrees. Okay, so our last one is actually very similar to the one we just did here. Again, we're given an angle up here at B, but we don't know the side opposite it. So we know we can't use law of sines. And to find the missing angle, we need to know all three sides. So you're going to need to find this side length first, again, using the formula like we did in the previous three problems. And then you can use one of our angle variations to find the angle at C. So go ahead and try that out. Pause the video and unpause when you're finished. All right, you should have come up with hopefully a side length of B of approximately 25.6 rounded to the nearest tenth. And then using that value and plugging into, you could use this version if you wanted to follow the A, B, and C exactly. But for finding the angle at C, it starts off with the side length opposite it squared minus the square of the other two lengths of each of those, and then all divided by negative 2 times the other two lengths. All of that inside of our arc cosine. So here's the Desmos. To double check both the length of 25.6 and the angle of 52.4 degrees for our final angle. Okay, we'll definitely do more problems like this in class. Make sure you ask questions if you're unsure.